I'm seeing a black screen. You guys see my screen, or you seeing black too?
Yeah, we can see your screen.
Okay, cool. All right, so today we're going to talk about Goodbye Lambda and Hello Kubernetes, which is basically the journey that we've taken at FloSports from one platform to the other. And it's not going to be a deep dive on Kubernetes. I'm sorry. I do have some experts on the call, though, from FloSports that can help answer some of those questions at the end to dive really deep. Really, this presentation is going to be more about why we ended up with Lambdas and then why we ultimately moved away from it. So first, just to introduce myself, my name is Jason Byrne. I'm the VP of Engineering at FloSports. I've been at Flo for since 2013, so going on 8 years. At Flo, I manage a team of engineers as well as a team of engineering managers. Work with a great team. I don't know how many we're up to now, maybe about 50 in our product and engineering team. And we're going to hopefully be adding another dozen or so here soon. So we're definitely expanding. I do a lot of the architecture work at FloSports as well as some of the R&D besides just the management. Before FloSports, rather, I had a startup called MileSplit, which if you happen to be from the track and field space, I'm sure you know about, but I ran that startup starting in college. And then I sold it to FloSports in 2013. And so that's how I joined FloSports. So all that to say, I'm really, really old. I've been developing basically since there was a web to develop on, starting back when I was in middle school. So I've done everything from, Visual Basic to Flash and ActionScript to, DHTML. So yeah, I just turned 40. So I'm feeling really over the hill now when most of the people in ODevs are much younger than me. But anyway, so that's who I am. If you guys want to get in contact with me, I'm happy to have you reach out on ODevs Slack or LinkedIn, Twitter. There's my personal website as well as my FloSports email address. So feel free to reach out. All right, so next I just want to tell a little bit about FloSports. If you don't know about us, we are a direct-to-consumer sports media company, which basically means that we love sports and we stream, our bread and butter is live sports. And more specifically, we go after what we call the underserved fan. So, ESPN, NBC, ABC, they've got the NFL, the NBA and whatnot covered, but there's a lot of these sports that are on the edges of popularity that are not quite mainstream that actually have really large fan bases. So if you think about like your wrestling fan, like Olympic style wrestling, they only are on ESPN like once a year, but they crave this content 365 days a year. And we say that like even within our mainstream sports, there's these underserved fans. So for example, we do have some D1 college NCAA football because there's some of these colleges that never see themselves on network television. So we get deals with a lot of these conferences and bring them to the masses. And we've had a lot of success with that. Sports you wouldn't think about like marching band and dirt track racing, track and field, which is my background, cheerleading. So anyway, that's who we are at FloSports. So live streaming and live events are bread and butter, which also brings a lot of challenges because a lot of our stuff happens and we get floods of people all at once, which I'll talk about in just a bit. Already plugged it, but we're hiring. So we have probably they're not posted yet, but we have probably a couple posted now and probably about a dozen more engineering positions to go the rest of this year. We're going to be slowly rolling those out. So plenty of positions. We have our headquarters is in Austin, but we also have an office here in Orlando, actually in Longwood, as well as remote people across the country. So would be happy to talk to you and have you guys join our team. All right. I mentioned earlier, this is the presentation. I'm going to move pretty fast. It's not meant to be a deep dive. We can dive a little deeper after the fact, but there's a lot of material here. And I realized going through it, like I could have like 5 different meetups on this stuff. So I'm going to keep it high level, but save your questions and we can dive a little deeper at the end. I was also told by somebody that how to make a better ODevs presentation, the more animated GIFs, the better. So be prepared for that too. So first I'll talk a little bit about the architecture of our live streaming platform, which is what we're talking about today. This is a drastic oversimplification of our live streaming architecture. But basically we have our video origin, which is where the live stream is encoded, which pushes to a CDN and which pushes to the user. We're on every single different platform you can imagine just about. And we also have an API that is the thing that authenticates people and tells them where they can go to the CDN to get the live stream and things like that. And that's actually what we're going to be talking about today. That's what we moved from Lambda to Kubernetes, is our live streaming API. So the old way that we did our live streaming API was kind of your traditional monolith that was based on PHP Symfony. We were on Amazon Web Services using ALB load balancers and EC2 instances. And so basically every week we would have a meeting and we'd say, okay, here's how much traffic we project this weekend. We need to go ahead and scale up our servers ahead of it just to make sure we have enough. And the problem with that is, one, if we estimate too high, we end up paying for a lot of resources that we don't need. And we can actually be unprofitable at the event if we shoot too high. But if we shoot too low, then we're going to run into a situation where we don't have enough server resources. So you guys are probably, next question is, well, don't you guys have auto scaling? Everybody has auto scaling nowadays. Well, we do have auto scaling, but due to the nature of live streaming events, what we see is a stampede effect. Like we see, like when the event starts or when a certain moment happens and things go viral, we get a bunch of people coming in all at once. And so if we only rely on auto scaling and we don't kind of pre-provision some of those excess resources, though with the EC2 platform, it takes several minutes for new resources to come online. And we found ourselves very often not having several minutes. We needed it now. We needed it within seconds. So that was a major problem that we have with this. The money issues, the bunch of oversight we had to have. And again, the going down at exactly the wrong moment, because you're left going down at your biggest event and the CEO is never very happy when that happens. So after one of those moments of downtime, I had a heart-to-heart with our CEO. And again, those are never very pleasant. And so like after this long drawn out conversation, he's like, Jason, gun to your head. We can't go down. What do you do? What do we do to our infrastructure to make it better? So I said, I don't know, but I know that I wouldn't do what we're doing now. I know that it wouldn't look like this. Let me think about it. And so I thought about it a little bit longer. And the more I thought about it, I just had this aha moment. And this was like 2017. So this was very early on in the serverless, thing. And not a lot of people knew what serverless framework was or even what Lambdas were. But I was thinking about, it's like, this would actually be perfect. This is like everything that they've ever told us that serverless was going to do. The problem that we had was that none of our people on our team, nobody at FloSports had ever done serverless, had ever done Lambda. I mentioned our frameworks were largely based on PHP, and I wanted to go Node and TypeScript. So it was a big challenge when I go to the team and I say, guess what, guys, we're going to rewrite everything that is the core of what we do at FloSports, which is live streaming video. We're going to rewrite it. We're going to bring on an entirely new technology stack that you guys have never seen in your life. But thankfully, we have a really great team who embraced that challenge and didn't tell me that I was crazy. And we did. We said, okay, we're going to do this. And so that's when we started our Lambda and serverless adventure. And again, really drastically oversimplifying what the architecture looks like. But basically what our solution with Lambda looks like is we have the sports fan on the end who's hitting our API. AWS has a service called API Gateway, which is kind of your traffic cop, if you will, kind of like a load balancer, but it kind of, so with Lambdas, you take your API that was once a monolith, and now every single function is an independent Lambda. It scales independently, lives independently. And so you have this API gateway that sits in front of that and says, oh, you want this endpoint? You're going to go here, and we're going to pass through these headers and these whatevers. And so it directs this. And so that's what API gateway is. And then your behind the scenes, you have, again, every endpoint is its own Lambda, and essentially your code sits there cold. So if nobody accesses your site, you're actually not paying for anything. There's no server resources running. And it's beautiful. You pay for only what you need down to the millisecond. And then as as people start coming to the site, then it ramps up these server instances within seconds and start scaling them out to more and more and more and more server nodes, but completely transparent to you. So that's kind of drastic oversimplification, but that was really exciting to us to do. And again, now we don't have to have those meetings every weekend and worry about scaling up because there's no servers to scale up, right? So it's beautiful. So again, here's some benefits. The promise of Lambda and serverless is so great. Scales down to 0, pay only for what you need. You don't have to pre-provision. You don't have to worry about really scaling out. It does it all for you. Every function is independent. I put a star there because you have to be aware of backend dependencies. Like every endpoint is on its own until you start accessing the same database or the same caching layer. So you do have to be a little bit careful about that because that's an easy trap to fall into. Forget about that part. But all these great promises, the deploys are supposed to be fast. The serverless framework was great to work with. Kind of made it easy for us to kind of develop it similar to a monolith, but deploy it separately. Fantastic. Just we were super excited. And for a little while, this worked great. We were able to scale and do bigger events than we had done before. For the most part, we stopped getting calls in the weekends for things crashing, and we're like, we have done it. We have arrived. We are gods of programming, and kind of really pat ourselves on the back. And I was interviewed on Akamai TV out at NAB in Las Vegas talking about this framework. I'm like, yeah, it's great. It's fantastic. But the problem is that we kept growing. So, what was once fantastic started to slowly have cracks develop in it. Like we didn't see them at first, but as our traffic grew and grew and grew, and we did bigger and bigger events, we're like, well, everything isn't quite as rosy. So I want to dispel one thing, because anybody who knows anything about Lambda probably thinks, oh, they ran into cold starts. Because that's what everybody says is the negative about Lambda is, oh, cold start. So a cold start is when you do pull your code from 0 and bring it up into Lambda. There is a couple seconds delay, but we actually didn't have the problem with cold starts. And I equate that probably to the fact that we do have, pretty consistent traffic. And so I don't think that any of our main endpoints stayed cold. They were always kind of warmed with at least one server instance. So that wasn't really our problem. This is the minor of our problems, but I'll start with this one. The deploys weren't nearly as seamless as advertised. So one thing is that our API was pretty large and we had a lot of different functions, and there's actually limitations on the stack size, is what they call them in Lambda, like how many functions you can have in each stack. So we had to develop these custom plugins for serverless to like do stack splitting and have multiple stacks and shuffle them in and out. And it was pretty complicated and didn't work nearly as well as we thought it was supposed to work. And what we found is in the process of switching those stacks and kind of migrating out one version for another, there was actually downtime. And so we couldn't deploy new code updates whenever we wanted. We certainly couldn't deploy it during events. So we were left like trying to deploy in the after hours, which, increasingly with our global traffic, there's less and less downtime, without events anyway. But the biggest problem that we ran into is the Stampede issue struck again. And that's what I talked about earlier, where when a live sporting event happens and we have a bunch of people rushing in the door, that wasn't supposed to be a problem with Lambdas, but we found out that it was. These Lambdas did not scale out quickly enough. And the best way that we can surmise it, what we started to see is throttling. Amazon has all these different throttles that you can only add a certain number of Lambda nodes in a certain period of time. You can only have a certain number of concurrent Lambda functions running at a certain period of time. And so we kept running into one of these after another. And we'd reach out to Amazon. They're like, oh, you have to raise this limit. And they wouldn't tell us. So they'd raise that limit for us. But then right behind that, there'd be another limit, another throttle that they didn't even tell us about. And we were kind of like, it would be nice if last time we asked about that throttle, you would have told us about the next one. So we were getting really frustrated hitting all these limits. Some of them were ones that we could file a ticket with them and say, hey, can you raise this to 100,000 concurrence or whatever? And they would say yes or no. Sometimes they wanted more information, but some of them they would raise for us. But some of them they told us were hard caps. They said, we can't raise this. This is the same for every user and every person, every customer and we can't raise it for you. We had limits on number of functions that we could have. We had limits on what we could do in each subnet. We had limits for the overall number for our account. It just was one thing after another. So we talked to Amazon and we said, well, what should we do about this? And they had two suggestions, both of which we thought were really silly. One suggestion they gave us was, well, maybe you guys are better suited to go back to an ALB EC2 setup. So they were like basically like bailing out on their whole premise of the serverless Lambda thing and saying, well, maybe this isn't for you, and for your application, it might be different. We're like, you guys, the promise is that this solves our problems, and in reality, it doesn't. So we thought that was kind of crazy that was their suggestion. Their second suggestion they made is that we could set up multiple AWS accounts because they had these hard limits that they wouldn't raise. They said, but if you set up multiple accounts and you shard between them, then you can get around those limits. And I was just like, that's just a silly suggestion. You have these arbitrary limits that you've put in place that you don't let us, and you're just trying to make our architecture more complicated. So needless to say, increasingly, we were not very happy with our Lambda solution anymore. And we lost some sleep and had to worry about the events again. One of the things that we did not try that we could have tried is Lambdas do have this thing called provisioned concurrency, which is essentially the same thing as we were doing before when we had these meetings ahead of the weekend and we said, how many servers do we need to run, when we were on EC2s? So we could have done the same thing and had provisioned Lambda concurrency and paid for, and mind you, we'd have to do this on every single API function, because with Lambdas, you provisioning concurrency on independently on every single API endpoint. So we could have done that, but it didn't seem like a lot of fun, and it seemed kind of anti, everything we were trying to accomplish. So that's where we were in our problems with Lambdas. So at the same time, and kind of independently of what we were doing with Lambdas, we were getting more and more experience with Kubernetes. And actually, Samir is on the call. He was our evangelist internally at FloSports for Kubernetes. He freaking loves Kubernetes and was telling us for like 2 years how amazing it was. And we were like, shut up, Samir, like, who cares? But eventually he beat us down and we started learning about it. And we were actually like, okay, this is onto something. So independently of what we do with our live API, we started realizing that we had a different kind of problem at FloSports. And that was, we had all these different teams with different products, and they were solving the same problems over and over again. They were, every single new product you had is like, okay, well, how are we going to deploy this? How are we going to do logging? How are we going to scale this? What kind of infrastructure we're going to put it on? Yada, yada, yada. It's like, why do we have to solve the same problem every single time? Why do we need to spend developer capital and overhead to figure out these things? Like, we want our developers just focusing on writing an application, and that's it, not worrying about all these underlying backend infrastructure stuff. So we started envisioning what kind of system that we could come up with. And I'll give a little credit. There's a company in Australia that actually did these Jupyter images, and it was a Medium post that I saw, that they had this idea of like your app being the eye of Jupyter, and like all these layers were the different things that you needed for your application. And the ultimate goal was for your developers just to worry about the eye, just to worry about the app. And like the rest of it just kind of came with it. You got it for free. So that was kind of the inspiration behind it. So our DevOps team went from being something where either we needed to embed a DevOps person on each team, product team, or from a team where all the product teams put in a ticket and had to request DevOps do something for them, to really thinking about our DevOps infrastructure team as more of a product in and of itself. They were creating an internal product, and their internal product was this new services framework, as we called it. And so again, everything is solved for you as a developer. You get the logging, you get the networking, you get the security, you get everything is just done for you. You get the CI/CD deployment with GitOps. You just follow the pattern that they have, the trail that they blazed for us, and it comes for free. And so we rolled that out, and it was fantastic. And so just a very, very high level here. This is the framework that they rolled out for us was using Docker. Hopefully you're familiar with Docker. So every team, when they created a new application, would create a Docker image with a Docker file and kind of define what dependencies they had, what operating systems, et cetera. I won't dive into what Docker is. If you don't know, can ask at the end or do some research, but it's based on that. And we also based on Kubernetes, and Kubernetes is basically a Docker management system. So Docker in and of itself is good, but you can get in a situation where you're still running EC2 instances that you need to manage all independently and scale and all that kind of stuff. So you're not necessarily a whole lot better off. So Kubernetes comes along and says, let me handle all that stuff for you. And so you create like a cluster of these nodes, and Kubernetes can scale that up and down for you. It can worry about, how the request for this application comes in, and and it knows that you need to talk to this certain Docker node. It handles all that for you. So Kubernetes is a fantastic platform for doing something that otherwise would become a pain in your butt very quickly. I want to dive again too deep, but this is a little bit of a look what it looks like. The Kubernetes Master sits in front and it manages different worker nodes. And basically you can think of those worker nodes as servers, and it can add more and add less. And then within each node, you have the different pods, which are your actual applications. So you can run, the cool thing is, where before we might have had to scale every single product and application separately. We have to have a cluster of servers for product A and a cluster of servers for product B. Now we just have a cluster of Kubernetes nodes, and all of our different applications can run on those same nodes. So that means we share resources, which means overall we have a whole lot less servers infrastructure that we're paying for, and they can scale up across all of them. Again, I'm being very high level here, and we're happy to dive in deeper a bit later. So when we decided to go to Kubernetes, the next question we had is what platform do we want to use? We could use Google Kubernetes Engine, we could use EKS, we could use AKS, so that's like Amazon products, or we could do it self-managed. We ended up deciding that we like GKE. Universally, everyone on our team who compared the two products said GKE is the best product, which makes sense because Kubernetes was developed by Google, so it makes sense that they would have the best Kubernetes platform. The only downside is that we were previously an AWS shop, and so moving to Google Cloud wasn't that simple. It wasn't just a matter of like, okay, we'll use GKE instead of EC2s or Lambdas. It was that we had to move our database over, our cache over, our the simple notification service and the SQS service. We had to move everything over because you really don't want to cross clouds because it's just not efficient to do. So it was a whole lot of work, but eventually we did get it going. And the result was that our developers were freaking happy. And that it's just such a relief that you can just write code, set up a few configuration files in your repository, and then literally you just push code to your master branch and it deploys to staging. And if you add a tag to it, then it will deploy to production, run all your tests, do whatever automation, like all that is handled for you in this beautiful system that Samir and team created for us. So we did that. All of our new applications and some of our existing applications were moving to that. And then that left our live API team like, can we have that too? So they were stuck in this Lambda thing that we had migrated to with all these problems, and they were pretty jealous. And, we had these real scaling issues we need to get over. So, again, we developed that Kubernetes system independently, but ultimately we said, this just makes too much sense. We're going to bite the bullet and we're going to move away from serverless, away from Lambdas. We're going to move onto this Kubernetes platform. So we did. And again, there was a ton of work to get this to move. We had to move our databases, our Redis, our PubSub. We had to, our serverless, even though we could reuse some of it, there was a whole lot of code that needed to be, rewritten or at least ported over. We settled on using NestJS, which is a TypeScript framework for APIs. Kind of, you can run it. It's kind of on top of Express. It's great for APIs. I highly recommend it. So we ported all of our serverless stuff back into kind of a monolith with NestJS. And we had to port the QA testing because all that, of course, changed. Deployment pipelines all changed. But one of our product managers likes to call this peeling the onion because it always sounds simple on the surface, but you peel and there's another layer and another layer. So, and to have the image there, like repairing the plane as we're flying it, because all this is happening, we still have live events. So we have to figure out how we're going to do this piece by piece in a smart way to test it while we're still putting on all these live events. But lo hicimos, we did it. We were able to fully switch over toward the end of last year. I think it was in the fall, maybe Q3 of last year. We moved 100% of our stuff over to the new platform, and huge relief. Did it work? And all signs point to yes, it did work. We were able to flawlessly pull off our largest ever event just this, I think it was in January. And load tests confirmed that we ran load tests like far and away, like 4 times higher traffic than we did with Lambdas and 4 times higher than we've ever had to go with events today. We were able to service on this framework. And so now we can go to our C-level people who are out there trying to get sporting events right. So we can say, hey, you can go after bigger events now. Like we no longer have to worry about this. We do still have some other thresholds that we need to get over, other parts of our infrastructure, but this live API is no longer one of those concerns. And so it's super exciting to be in that place. And that I'll shut up a little bit and give everybody a chance to ask some questions.
Awesome. Thank you, Jason. That was really, really good. So I'll open it to questions as well. If anybody, you can unmute yourself or ask in the chat or however you like, whatever you're most comfortable with. So I'm curious, like, so when you went from the serverless to back to the monolith, I mean, did that, obviously it helped with the scaling issues, right? But do you find that, like, cause one of the things that you tout of like doing serverless in general, right, is that it's easier to maintain because everything is very, has a single, like, purpose. I forget, my terms are failing me right now, but anyway, do you find from a code maintenance standpoint, it's any more difficult going back to a monolith? Or
so when I say a monolith, what I really mean is that our live API, which is kind of an independent thing in and of itself, is a monolith. Mm-hmm. And so, when you're in serverless, you're actually deploying every function independently, where it's kind of like very, very microservicey, right? Every separate. This is one, the whole API is run on one application within, one node container.
Okay. But then
so
that API is then calling endpoints that are separate. Like, so it's not like all the code is it's not like a big monolithic application. You're still saying some of this is all split up into functions and stuff like that.
Just this one API, right? But we have a lot of other services running on this Kubernetes system. So we have, our web front end, our web API, like all the just a ton of different services, probably dozens of services by now. Running on this Kubernetes. And so those are all separate little applications with their own separate Docker node or pods, I think is the right term. And they can share the same resource. They can share the same servers. Samir, do you want to give any better explanation than I'm doing it?
Yeah, I mean, so one of the key sort of issues to think of with Lambda, like, on the surface, it makes sense. You're like, oh yeah, I'm running a bunch of these little functions, and that's great because, nothing is going to interfere with each other. But the reality is that each one of those functions has its own sort of scaling limits. And so it's like, how many requests can you take at the beginning of the curve? How many can you sustain? What happens after you hit that limit? And so on and so on. And so now, instead of having one problem, you have, dozens and dozens of problems. And even when you deploy, if you start off with the serverless framework, it just deploys it, no big deal. But if you end up with, let's say 100 or so functions, you end up with these limits in CloudFormation. With the deployment, you could only have like 10 or 20 or something like that per CloudFormation stack. So that really complicates your deployment process, and it does cause some downtime. So yeah, there's lots of things to consider.
Hey,
Very cool.
Hey, Samir, maybe talk about the HPA a little bit and explain the, sort of how you go from that monolith to these, virtually limitless scalability, that we get.
Yeah, so the cool thing with Kubernetes, I mean, if you want to set up Kubernetes on your own, you're probably going to do yourself a disservice. We're using, as Jason mentioned, GKE, which is, Google's offering. What's cool about that is they have, the notion of auto scaling like Amazon does, but on the cluster level. So your server has what's called a node pool, which is a collection of servers, and you can set a minimum and a maximum for that node pool. And that node pool essentially can have all of your applications running inside of it. And you can have a fair amount of headroom set up such that if any of those applications starts expanding within the pool, within that cluster, you can have what's called an HPA, which is like horizontal pod autoscaler policy, which is basically the minimum and maximum amount of containers you can run for that given application, and have some sort of, you could say if the CPU for my entire set of containers gets to 50%, add another container. And so then when you add another container, that drops the total down to 45%, let's say. And so as your app sort of expands within the boundary set by the cluster says, oh, these applications are consuming more resources. I need to expand myself such that I can accommodate more of these containers. And so the cluster auto scaling has the same property as the Amazon VMs. It takes anywhere from 2 to 3 minutes to get a new server up and running, but the containers can spawn up more containers in milliseconds. In maybe 200-300 milliseconds, you get a new container. And if it's a small image, like something that you would run in Node.js or Go, you could get it in like maybe 50 or 60 milliseconds even.
So just to nail down the point, like we have, again, many dozens of different applications. Some are big, some are just microservices, but they're all running within the same resources. And so while we do have to have that headroom, we do have to pay for the capacity that in theory we're not using, because we always maintain that headroom. It's across all of our applications. And so within that headroom, the Kubernetes can spawn up all these different things to handle that one specific application, scale up that one application within those resources we have, while it's starting to add some more servers. So you have that room. And again, you don't have to scale. You don't have to worry about scaling every single different application. It's over an overall dial that you dial up or dial down.
So that actually gets at a good point, which is George was asking here. You mentioned costs related to AWS, but if you compare it, was moving to this more expensive? Was it cheaper? I mean, or just on par?
I would say it's on par. This wasn't a cost saving measure for us, but it also wasn't anything where we said we're going to spend twice as much. I mean, I will say all in all, Lambda was a pretty efficient cost wise for us. But I definitely wouldn't say this is, I don't have any hard numbers, but there wasn't any spike. Like we didn't have to sweat that.
It's not so much more expensive, even if it is, that anybody cared.
and I think all in all, it saves money as we move more and more stuff to it, because again, we're sharing the same resources across all these different applications.
Right.
And maybe other companies don't have to worry about that. Maybe you only have 1 or 2 applications, but we have a lot. So
right. Well, and I suppose the being able to scale up and sell to bigger events and stuff like that is more important to them than whatever nominal costs you might have.
Absolutely.
So, okay, cool. So why not Azure, David? David K is asking. He's pimping his employer.
Why not
Azure?
None of us have ever used Azure. And so I have nothing bad to say about Azure. I also have nothing negative to say about Azure. We used Amazon for years. We had some folks who were experienced using Google Cloud and had a good experience with that. And Samir really loved GKE. So I don't have a good answer for that other than that we didn't know Azure, and we didn't really look at it. We felt like Google was a great solution for us.
Yeah, cool. I think like Charlie might have evaluated Azure at one point. But really, at the end of the day, like the conclusion that we came to is that the developer experience to log in, to get access to Kubernetes and to be able to do your job, all you would really need is a Google account. And once you have that Google account, you install the CLI tool. And it's just a handful of commands that we could just write down and tell people, hey, just type in this command and you will get access to Kubernetes. And that was not the case for EKS, or I would imagine AKS, or even the DigitalOcean offering. There's a lot more setup that goes into, getting it set.
Yeah, I actually personally wasn't part of the evaluation, but again, universally, everybody said, GKE is the most mature, polished way to run Kubernetes. That was our estimation.
So Tuan asks, sorry if I'm mispronouncing your name, says, I have a side question on moving from AWS to Google Cloud. Beside the benefit you mentioned about Kubernetes, how about cost and management?
I mean, I think there's so much competition. Each of the companies are keeping themselves in check. They're really pretty equivalent.
Okay, cool. Anybody else have any other questions? We're still open for questions if you want to put anything else in the chat, or again, you can unmute yourself and ask a question.
Yeah, we got our experts on the line.
Yeah. Any downsides?
So anything about Docker, Kubernetes, even Lambdas? Like, I mean, we have a lot of experience. They were happy to.
Any downsides on Kubernetes at the moment? Like, have you run into any kind of things that you'd warn people about?
You know, with any kind of new technology, you don't want to be like too far behind. You don't want to be first, and you don't want to be last. You want to be like somewhere in the middle. So, you know, we're trying to hit that sweet spot of staying in the stable channel, so to speak. But there are some deficiencies, you know, not gonna lie. One of the issues is with Ssl certificates. We have to manage our own Ssl certificates within Kubernetes using this technology called Cert Manager. It's an open source tool that's out there, and that, you know, as of this weekend, actually, this Sunday, it sort of ran into some issue, like it didn't update the certificate. And on the Amazon side, you know, you have ACM, which is pretty comprehensive. It'll automatically rotate the certificate for you. It'll, you know, do all this other automation. You can have wildcard certificates. Google also has that, but they have some limitations, and that's why we couldn't use their managed offering. So it's little stuff like that, you know, that you sort of look at and you're just like, oh, they still need to do more work to sort of get it to where it needs to be. But overall, the offering is pretty good.
Awesome. Okay, what's Douglas was asking, what's the biggest drawback? Is it just the SSL cert issues? Sounds like that's the case, right? There's no other big drawback somebody should be aware of, like, oh, you know, you get these things, but you might, you know, you kind of have to compromise on this.
I mean, I don't think for us, it ended up being a necessary win, but I mean, we still do have to say, well, do we need to scale up for this weekend? So, you know, if Lambdas work the way they're supposed to work, we wouldn't have ever had to ask that question. But we do have to ask that again. Again, it's much easier because we just kind of dial it, scale of one dial, but we do have to say, okay, we're going to have a really big weekend coming up. We're going to have this traffic surge. Our team, we have a team we call the Oracle, and they have all these machine learning stuff they built to predict how much traffic we're going to do, how many viewers we're going to have. And so we're like, okay, they're predicting we're going to have X number of, you know, tens of thousands or hundreds of thousands or whatever. And so we need to scale up to this level. So we still have to ask those questions. We still have to kind of tweak the dials a little bit. It doesn't, for that Stampede effect, it can't quite scale itself quick enough. But
Jason, some of the scaling is database too.
Yeah.
Like the SQL
absolutely. And Redis and, you know.
Yeah.
Yeah. Okay. And that's the important thing to remember, like whether you're in Lambda or Kubernetes, it's not just the application layer that you have to worry about scaling. You have to think about, like, what is every other dependency you can possibly think of, including vendors, because that's the other thing we've run into when we've still had some downtime. We're like, okay, we've got our shop completely buttoned up. We know everything is scaled to the nines. And then there's this one vendor that we forgot to tell them, like, we're going to have this big event this weekend. And they're like, holy crap. And like, we take down the vendor. So, you know, there's always something that you forget about and have to think about. So it doesn't solve everything for you.
How long was the migration process?
Probably about 2 quarters.
So 6 months.
Yeah, and we like to do everything in phases. So, you know, we roll it out bit by bit, like maybe one endpoint at a time, or one, you know, piece at a time. Or a lot of times, what we'll do, we'll when we think it's ready, we'll put one event on it, and then we'll put 2 events on it. And because we don't want to like flip the switch and be running everything on it, or and not as much, but in some cases we might be able to put a little bit of traffic on it, just like an A/B test almost. But so we ramped it up. We, you know, did the port migration, and we ramped it up over the course of a couple of quarters.
Okay, cool. Any cold start issues, Dennis?
With Kubernetes?
Yeah, it sounds like no, because you have it basically you have a baseline where it's always basically warmed up.
Exactly.
Awesome.
Just to be fair about that, though, there is going to be some measurable ramp up time. You know, when we did the Stampede test, you know, we couldn't start from one container. We wouldn't have been able to scale that quickly. So there, we did pin up a sort of a minimum number just because we had to leave some headroom to give the system a chance to scale up. So there's some, but it's so minimal.
So to Steve's point, we've done a lot of work also with our infrastructure team on really maturing our load testing platform. And so, you know, we are doing load tests all the time now. And so we can say, you know, what ramp up time that has. So we're going to do, you know, 400,000, you know, concurrent users, but we can also control like how quickly that traffic ramps up. And we can make it have that stampede effect where they all come at once. And if we do those really big stampedes, you know, that's why we still have to have those meetings where I mentioned where we still have to say, okay, we have a really big weekend coming up. We need to dial up that dial ahead of this weekend. And so we have to still do that. It just, you know, can't heal everything.
So one last question from Steve asks, do you use Docker for your dev environment at FloSports?
Yes. Yeah, absolutely. We did Docker for our dev environments before we started running Docker in production. So we have years under our belt of running that for our dev environments.
Awesome. All right. Well, thank you all. Thank you, Jason, and thank everybody else from FloSports who came in to kind of fill in extra details. That was awesome. I really appreciate your time here, and thanks everybody for coming. We will have another meeting next month. I haven't set it up yet, but I promise you it will happen. And then hopefully sometime in the you know, maybe in the late summer or early fall, we'll actually get to meet in person. But until then, we'll see you online. And again, reach out if you're not on Slack. Feel free to reach out to me, brian.rinaldi@gmail.com, and I'll get you invited. Okay. Thanks, everybody. Bye.
Bye.
Bye, y'all.